All right. Oh my gosh. Rational functions. Tell me what rational means. I know you know this.
Oh, it's the
Makes sense.
It's another F word, but it's not factor. No, not the factor.
Function.
No.
Maybe function on the
It's probably your least favorite F word in math.
Fraction.
Fraction. Fraction. We're talking about fractions. All right, so let's talk about some things that happen with fractions, and then we're going to expand it. So rational functions are really like polynomials divided by polynomials. And I'm telling y'all, I did this with one of y'all. So if I did it, I'm sorry, and we'll whatever. But let's talk about some things that happen. Let's rewind back to Algebra 2 just a minute. Whenever you have things like x, y over 2xz, what happens? How can you simplify that? Okay, no. You can take the x's out, right? They cancel. And they're canceling because this is multiplying, right? Really if you want the background, I could rewrite this as x over x times y over 2z, right? And that becomes 1, which is just the 2 because it's 2 times x times z. Actually do what? What you actually want to do, Wyatt?
Like 2 times x is 2x, which is more than 1x. No,
I'm not sure I understand the logic. Go ahead, Sonny. Explain it to him.
okay, thinking like
You're thinking like adding.
the 2 is bonded to the x.
Yes, that's his own.
Thinking about it like together.
I could rewrite it like this, Wyatt. Multiplication is commutative. Do you agree? What does that mean? I can flip-flop the order, right? So I could rewrite this like that. Is it still the same thing? Yeah. How about this? Yeah. So it's its own piece. It's independent of the others. Does that help you? Uh-oh, no, it doesn't help you. You're just saying yes because you're ready for me to move on from this? Okay. All right. So this kind of relates back to the kitten poster over there. We can't mark out those x squareds because you're adding, right? But if you're multiplying and you have it in the top and the bottom, you can cancel things out. So let's expand this just a little bit. What? Hey, because you can't do that. Do you like kittens or you don't like kittens? Oh, well. Right, so you don't want them to die, right? So don't do that. Because it's addition or subtraction, you can't do it. Now, if it was x squared times 2x times 1 over x squared times 3, yes, I could cancel those out. But as soon as it becomes plus like that, then no, you can't do that anymore. The x squared, yes. Yeah. And so, yeah. You can only cancel out top and bottom when you're multiplying. Never when you add or subtract. Good? All right. So let's expand this concept just a little bit. What if instead of just having these basic little monomials, top and bottom, what's a monomial? One term. What if I had polynomials? And in fact, I'm going to go ahead and give it to you factored, show you what happens. Rational function? Yes, it's a fraction, right? I got a function divided by a function. It's a quadratic divided by a quadratic. It's still going to be a function here. So my question is, how does that simplify? This time you're exactly right. This time, because this is being multiplied, right? That's the implied operation in between. And because these are the same, just like I marked out those x's before, I can mark these whole pieces out right here. Okay? Only when I'm multiplying. Notice there is addition subtraction here, but every addition or subtraction sign needs to be in parentheses before you start crossing out. In other words, if this was just x plus 3, something like that, the 3 and the x would go together. I couldn't cancel things out. I can only cancel things out that are being multiplied together. So I have thing 1 times thing 2 divided by another thing, and then I'm back to thing 1. That's why they cross out. Does that make sense to you, how that's doing? So this would simplify to x minus 5 over x plus 1. No, do not cancel those x's out now. Because if I went in, no, you don't even have to do that. Stop right here. That's the answer. I just canceled out here. Oh, I was just saying why you couldn't. Yeah. By the way, it's simplifying rationals. Go ahead, I'm listening, Delaney. No, it has to be exactly the same. So if it was x plus 3, x minus 5, x plus 1, x minus 3, that doesn't simplify at all. So that would be as simple as it gets. You're looking for things to cancel out, but it has to be multiplied things to cancel out. Does that make sense so far? Let me show you another one. Simplify that one. Place this one. Y'all agree or disagree? Tell me what, can I start canceling right now, first of all? Yes, because all the pluses or minuses are enclosed in parentheses, right? So let's cancel what we can. What do you see first that you can cancel? Somebody said the 2. I agree. Anything else? I agree. Anything else? So what does it look like simplified? I'm going to leave it in factored form, though. You're right, but I'm going to leave it in factored form. That's it. It's simplified now. I can't simplify it any further. Now, of course, you're not going to start with them this simple. Of course. Okay, so that was a little... no, just always leave in factored form. I should put that on. Always factored. You always want, before you start these, you're going to want to factor everything you can completely, and you're going to want to leave it factored completely. And there's a reason for that a little bit later. All right, so let's say we have something like this. And I said, simplify. What should we do? Let me put a little note here. Always factor everything first, then cancel. If you're taking notes and you want this in your notes. But Wyatt, you're exactly right. I'm going to do the little 3 thing first and then start canceling. What is that little 3 thing called? Why are you doing that? What is this? Difference of 2 cubes, right? So a difference of 2 cubes I'm going to set up, I'm going to do little parenthesis, big parenthesis, same change plus. Am I going too fast? Yeah?
Pardon the interruption. At this time, any student who has not already picked up a laptop, has not signed the paper to pick up one at a later date, and does not already have a laptop, please report to the library.
I don't know. You haven't got yours yet? I'm recording it. Oh my gosh. Yeah. In the first parentheses, 4x. We're looking for cube, not square, but that's all right. How about the second blank? Oh, yeah. Square the first, it goes in the first spot. Square the last in the last spot. In the middle is the two of them multiplied together. Everybody good? Don't worry about the signs. That's why we did the same change plus.
Wait, can you write like the rule somewhere?
Okay, so a cubed plus b cubed factors as a plus b, a squared minus ab plus b squared. And a cubed minus b cubed is a minus b, a squared plus ab plus b squared. Is that what you meant? Remind me whenever I'm done, and I'll see if I have a factoring special pattern sheet. I'll run you and give you for reference. If the internet's working. Oh no, ridiculous. I agree. Should at least get some advantage. It is an advantage though that we're over here and nobody wants to climb the stairs and come over here and mess with us. So there's that. No. Okay. Let's factor the bottom because we want to factor everything we can. Some of you were a little rusty yesterday with factoring, so let's just run through quickly. I hope Ms. Hutto pushed factoring with grouping. Factor by grouping? No, you don't know. You don't remember. Okay. All right, so multiply for White. Did you have Ms. Hutto too? You White. I had Wyatt. Yeah. Okay. Is that it that had Ms. Hutto? That's it. Yeah. All right, so multiply the first and the last together. What? I got 19 in calculus. There's 16 in y'all. Because I'm good, Wyatt. Aaron wants to take it.
We're like 8.
I know. I had 100% passing rate the year before. All right. Multiply first and last together. You get x squared. What multiplies to 12x squared but adds to negative 13x? Negative 12 and negative 1. Those are what's going to replace the 13 down here. So I'm going to have 4x squared minus 12x minus 1x plus 3 slash it. GCF of 4x squared and 12x. 4x. What's left if you take that out of the first two? The middle sign carries. What's the GCF of the last two? 1, because the middle sign is minus. It forces an opposite sign in the end here. So it leaves me with x minus 3. So factored, this is x minus 3. And then leaves me with 4x minus 1. Is that how she taught y'all to factor or no? Y'all don't know. Okay. Okay. It was, okay. We changed the last sign. Oh, that's only when there's a subtraction in the very middle. Right here, yeah. All right, so I got x minus 3 and 4x minus 1. Now every plus or minus that I have is enclosed in parentheses, so I am ready to start canceling out. What cancels? There you go. So simplified, this looks like this over. It does look bad. In fact, the first probably looks a little better, right? But it's not. It's not simplified. That's it. That's all you can do. You can if you want to at that point. Once it's factored completely and it's canceled everything out, it's up to you. That last part, the last part of the sum or difference of two cubes will never factor any further for you.
So what was your question?
Simplified. Okay, this is, I'm showing you simplify so that we can multiply and divide. We'll do add and subtract tomorrow. Today is just multiply and divide. I meant Monday. Or you're going to come white and you're going to like it. Just kidding. Okay. You try this one. Golly. Oh, it's going to be a long year. Simplify. Charlie, you're going to do this one on the board now. Come on. Get on it.
Water on my desk.
And yes, Sonny, use some more. Be careful.
Charlie's gonna work. Yes, I do.
I got one for Charlie. You got it working on the computer. I don't know. I've got an HDMI cord, but it doesn't have the touch hooked up. You got to do it on the computer. You can, but for some reason on the computer, the HDMI cord is supposed to handle touch.
So how would you go about this?
I did.
48 times 6. So.
Nice.
Okay, then on the bottom it's, I'm gonna just make a line.
Well, GCF, what's the GCF there?
Okay, so that's divisible by 6. So. Because 288 is close to 300, so if you add 12 to 288, that's 300 divisible by 6 is 50.
He just found the GCF. He just found the GCF.
At the bottom? No, because at the bottom, 18 is not divisible by 12. Yeah, on the top it is.
Alright, now what's he gotta do? Now he's got to, oh, it was divisible by something bigger, right?
Big, oh yeah, wait, yeah, 18, my bad. Is this the eraser?
There's an eraser thing. Just put equals and just do it again. Or slide over. Did it erase on the other end?
I think I did it. So that would be
What's that? Somebody already calculated.
16, right? The 16 squared is 256 plus 32. Don't worry about it. Yeah, so that's 16.
Yeah, that is because you're going to end up with a difference.
Then, yeah, that's just N2.
That's the difference of two squares this time. Yes, I mean, that's did you do that one? No!
Because it would be negative N squared. It would be negative N. It would be negative N squared plus 16, and then you can times it by negative 1, right?
You would have to factor out negative 1. that factors as 4 minus n 4 plus n.
Yeah.
Which is different than n minus 4 n plus
4 minus n times 4 plus n.
Did you do that?
That's the same thing I said. Flipping around.
You can't flip around subtraction. It's not commutative. But you're thinking on the right track because what Sonny just said about factoring out a negative 1, we are going to do, and I'll show you why. Let him finish factoring this out.
I'm gonna just keep going down with this.
All right, look at what he did, but you got to put a negative on the outside since you put it.
Like that?
Put it out front the 18.
Alright.
It's Cindy's birthday.
Oh, happy birthday! All right, look at what he did because this is important. You have one of these on your test, so I want to make sure everybody understands.
Use the stool.
Because
So it's just going to be negative 18n. No.
okay, look. Finish factoring this one out, so
Alright.
This is what I'm getting ready to handwriting.
okay, you're still on the right track.
It's not that bad. That's a 4.
All right, look. Everybody look. This bottom. The bottom. Because when this factors, it's very close to us on the top in order to cancel out. It was just a wrong sign. He factored a negative out to make it easier with factoring. And the reason that he needed to do that was because now look, you have an n minus 4 and an n minus 4. He saw it a little earlier than what I probably would have seen. I probably wouldn't have seen it until I factored this and got 4 minus n, 4 plus n, and went, that's really close to what's at the top. Can I rearrange them anyway to make them to where they cancel? So I'll work it that way in just a second too to show you. Go ahead and cancel out what you can cancel out, Sonny, and then I'll come. Yeah.
Okay, so it's 16 minus n squared. So what I was thinking is, you know how like letters go like before the thing, you know, generally when you're doing difference of squares. So if you flip this around,
You didn't do it because you saw that it was going to cancel. You just did it because you wanted to feel better.
it becomes that kind of messed up that negative there. Okay.
It's okay. All right. It's okay. It's all right.
Don't worry about it. Okay, but like.
At least you know there's going to be like a really big curve along like that.
Even if there was, there would be a big curve.
You would look for everything.
So,
Yeah, somebody took the exam for fun. I made like a 98.
no, I took the exam because I had like a 90 and I wanted to see if I could get anything.
There on the bottom side.
Huh?
There's a squared here, and then one of the ends is going to cancel.
The square. Wait, what?
Yes, you can simplify that too. They're both divisible by.
Yeah, you can simplify that, but you said something about an n? Like this?
All right, let me
or-
start it from the beginning and let me show you.
Sentence multiplication would end up being 12 over negative 18. Y'all said the end is.
It's supposed to be there. Okay. All right, let me take it from here. At this point, does everybody see the very first step, how we took that GCF out right there? Okay, so for this one, I could divide them both by 12n, and I could take that out to leave me with n minus 4, right? And then this one, 288 divided by 18 is 16, and 288 divided, or 18 divided by 18 is 1. So I just took the GCF out first step. Are you following me? Okay. All right, so now let me go from there and let me walk you down, because I think most of you got to this point and then went, what the heck is going on? If I'm working this problem, I am still fully factoring, okay? I wouldn't have seen to take the negative out yet, so here's what I would have done. I would have said, okay, well, I know that on the bottom there's a difference of 2 squares, right? I'm going to factor them like that. So I'm going to say 18n squared, 4 minus n, 4 plus n. Does everybody agree with that? All right. Now, I can go ahead, if I want to go ahead and simplify this a little bit, fine, go ahead and do it. I hadn't got there yet. Notice the order of mine is different than the order. Sunny's got n plus 4, I've got 4 plus n. n minus 4, 4 minus n. They're backwards right now, but I'm going to fix them in just a minute. Because these aren't exactly, right now you cannot do that. They're not exactly the same. For this is saying n plus negative 4. This is saying 4 plus negative n. That's not the same thing. Here the 4 is negative. They're opposite signs completely. Okay? But do recognize that they're really, really, really close, right? All right. First thing I'm going to do is I'm going to simplify the 12n and the 18n squared. I know one of the n's will cancel. And I know I can divide both of those values by 6, yes? All right. So it leaves me with 2n minus 4 over 3n, 4 minus n, 4 plus n. This one I could rewrite as n plus, bless you, n plus 4, no problem, right? Because addition is commutative. I can do it in any order. But the problem here, if I look and try to simplify these, every sign is different for both of them. Do you agree with that? Here, n is positive, n is negative. 4 is negative, 4 is positive. If you see something, I'm going to say similar factors. Everything is the opposite sign. Bless you. You want to factor out a negative 1 from one of them every time. Doesn't matter which one. Pick one. It doesn't matter. We just need them to look alike, and they're really close to looking alike right now, right? So let's just say this one. If I take out a negative 1, right? So I got 2n minus 4 over 3n. Now, this is still times, so I've got negative 1 times. If I change all the signs in here, I get negative 4 plus n. And now let me work with what I got just a little bit. And you don't have to show every one of these steps. I'm just showing you this because I want you to see where it's coming from. Up top, I have 2n minus 4. And on the bottom, this is multiplication. So this is negative 3n. And because this is putting the number first, I'm going to just switch this order around because now I'm addition, and addition is commutative. So I'm going to say n plus negative 4 and n plus 4. Well, aren't these two things the exact same thing? Is n plus negative 4 the same thing as n minus 4? Yes, indeed it is. So these are the same. And so I'm going to cancel them. So what I'm left with is 2 over negative 3n, n plus 4. Did you? Shut up. No, you didn't. All right. The end of the day today. I canceled what out? Oh, yeah. All right. Simplifying is never going away. It's something that with every operation we do, we continue to simplify. So I'm going to move on and show you multiplication and division. After we multiply and divide, then we go back and we simplify. Okay? When we add and subtract Monday, then we go back and simplify. So we're always going back to simplify. All right. Y'all ready? These are the easiest. I usually do everything all together, and you'll see whenever you get your homework, it's everything, but we're not. Okay. Yeah. Yay! Okay. Rational expressions are nothing more than what? Say it again, Smith. Fractions, okay? So let's review how we multiply and divide fractions because that will help us with this. If you multiply fractions, What do you do?
So this is like a new little section.
This is still the same thing, but a new little section in the notes. How do you multiply fractions? What is a butterfly? I don't know what they're talking about. They're back there like, what? Elephant!
No, it's cocoon. That's possible.
Cocoon.
Caterpillar.
It's butterfly.
Bumblebee.
No, I know. You like call multiply or top and bottom?
Make a butterfly.
That's cross, yeah, whenever you've got, when you solve a proportion. Okay, if I multiply fractions, let's say I asked you to multiply those two fractions, what do you do? Oh.
No, you gotta get the butterfly out of the cocoon.
Who told you basic math? Yes, Ellen. You just multiply straight across. It's top times top and bottom times bottom. Top times top, bottom. I don't even know what's going on right now. We're talking about butterflies and bumblebees and rainbows and elephants and like unicorns. Okay. What? Caterpillar, yeah. That's what I'm going to say next time. Miss McGee, how do you do it? Just caterpillar it. Okay, we're not doing adding and subtracting today, but you have to have a common denominator for those when you add or subtract. We'll go over that. Yeah. All right, so multiply. Top times top, bottom times bottom. How about division? Oh, I'm scared. Yes. So it's top. I should say top. I should say first. I'm thinking top. First times, and then you flip the second, and you multiply. So if this was 2/3 divided by 1/5, you would change that to 2/3 times 5/1, and then multiplication is not a butterfly, but yes, it's. Yes, I'm horrible at this, Wyatt. I'm really horrible at the butterfly. Watch and learn. How do you know which one goes on top?
Doesn't need to go on top. You just multiply.
No, which one goes in the top and which one goes in the bottom? How do
The
you
2 and
know?
the 5.
2 and the 5 go where? On the top?
Yeah, because the 2's already on the top.
Well, the 1's on the top.
Yeah, but the 1's on this side. You go left to right.
5's also on the bottom.
So that works really well if you remember when to use it and what it's for. Butterfly. Okay. Please don't fall. Please don't fall. Please don't fall. Okay. Let's apply this to polynomials and rational functions. I think I would not rely on a butterfly method if I was Wyatt. I'm just saying. All right. The key to rationals is factor everything first. Okay? Multiply, divide. It doesn't matter. Always factor first. You'll save yourself a lot of trouble if you do that. All right. So let's look at one. Let's say I have x squared minus 10x minus 24 over x cubed plus 2x squared times 5x squared minus 20x over x squared minus 16x plus 48. This looks a lot worse than what it is. Mark that Dr. Chung next door. I told her I was so sorry I'm so loud.
Who is that?
She took us out of his place. She's really nice. She went to another school. Chung. Chung. She has a doctorate in physics. She's taught in college and she's taught other places. She has I think she's got a master's in some type of music something too. Or something. All right, let's factor away, guys. I can shortcut that one because there's no leading coefficient, right? Y'all remember that? The two things, if there's a 1 in front, then the two things that multiply to negative 24 are the two factors. So what multiplies to negative 24 but adds to negative 10? 6 and 4, right? So x minus 6, x minus 4. Oh, good catch. 10 and 2. 12 and 2. Gosh. I can't imagine what could be getting my attention off of concentrating on this problem. I just couldn't even imagine. I'm over here thinking about, all right, so what multiplies to negative 24x squared but adds to negative 10x? Yeah, negative 10 and 2. I mean, negative 12 and 2. I'm still saying it wrong. You can only skip the work when there's no number in front here, when it's a 1. Yep. So same thing with this one, right? See the 1? What multiplies to positive 48 but adds to negative 16? Remember, we can only do this when there's no leading coefficient. Charlie, if there's a leading coefficient, what do I have to do? He's right. That would multiply what? Let's see if you know. No, you didn't. You're
It is time. If you did not make it to your class meeting due to being at WTC this morning or having late arrival, please report to the auditorium at this time. Any student who missed their class meeting this morning, please report to the auditorium at this time. Thank you.
If you have 4 classes, you didn't do it. Yeah, that's what they said. They said if you're a junior and you have 4 classes here, you did not do what you're supposed to do.
hold up a second. Talk to me after class. I'll tell you about it. All right. How about, can I factor the first one? The denominator of the first? X squared out. What's left? How about the second fraction up top? You can take out what? 5x. What's left? X minus. All right, let me write this a little neater so you can see everything. X minus 12, x plus 2, x squared times x plus 2, times 5x, x minus 4, over x minus 4, x minus 12. Are all of my pluses or minuses enclosed in parentheses? I am multiplying. How do I multiply fractions? Straight across. Straight across. I can cancel out. So what I'm going to do, since I am multiplying, I'm just going to do this. This is what I do because, okay. You could if you wanted to. I just tend to go ahead and make it one big fraction and do everything at one time. Because, no, it's less where I don't want to rewrite it. So now I'll just go ahead and start. These cancel. These cancel. One of these cancels. This cancels.
That wasn't that much.
Huh? If I'm multiplying, I just go ahead and make it one big fraction and cancel everything out. I look at it as one big fraction instead of. No. I was, but I go if I'm multiplying, I just put them all together. If I'm multiplying across.
How do you just cancel all that out?
Because you're multiplying since I'm the bottom. What you got, Max? Yes, I made so. All right, one more, and it's gonna be division, and then I'll shut up and let you do your work. Thanks, Wyatt. Day.
Always third block.
Thanks, Slade.
Always third block. Third block lasts for 2 hours.
Mark, set, go do it.
Butterfly.
You're gonna go back and do this one. This is division. Multiplication first.
Flip it and then do it.
Why are we doing this?
What?
We haven't gone over this.
I thought we were doing a multiplication and then moving on.
They just said we haven't gone over this yet.
You're confusing me. Multiplication is division. I mean, division is multiplication. Division is multiplication. You just have to
Flip it over, dude. Butterfly.
just butterfly it.
Butterfly.
You're gonna have everybody so confused on their test. I can't remember how to butterfly this, McGee. Am I supposed to butterfly on this one? Okay, clearly I have way too many copies because whenever I made these, I thought we had a full class. Like 5.
Or 30.
We're like 15 kids. All right.
Charlie, you okay?
Wait, is the butterfly moving LP?
Yeah.
Butterfly.
Charlie just had his head in his hands. I was making sure he was all right over there. I'm gonna pass the homework around. If somebody's left, just leave one on their desk and keep passing it. You're only doing 1 through 7. What's that? I have to keep up my reputation of being elder B. People might start thinking I'm a higher Do you think you're gonna have time to work in space class? No. I'll tell you right now. That's funny. Don't you have a weightlifting? You just said you had a weightlifting. I have 3/4 blocks too. I like it.
I like the hair, it's very long to have.
Fourth is my favorite, followed by second. I like first two though. If I had to guess, you're gonna have to take a negative out of that one just like before, but I'd factor it as it sits, 1 minus 2x, 1 plus 2x, and see if there's one that's close to that. Sorry. I told him I didn't want it this year. I'm so tired of throwing it all away and it drawing gnats and stuff.
Or eating rotten donuts for children.
Yeah, they're green.
Whose fault is that? You're not taking your donuts.
I know. why I said I'm not even. Y'all do get free lunch this year, though.
You just asked about the use of the use. Yeah. Like just like can you please ask for
And then yeah.
please ask for
Bro, I'm gonna have to go down there and get it.
Get it first one.
Nobody in calculus gonna go down there. They don't want to miss anything. That's why we don't want to miss anything. Calculus.
First person that walks in.
They don't bring it around anymore because our elevator's broke.
It is. What if like someone like brings their leg and you can get
If someone, I do this. I write as little as possible whenever I write because I'm lazy. I'll go ahead and factor off to the side somewhere. So 2x squared. What multiplies to 8x squared but adds to 9x? Why couldn't I shortcut this one? That's right. There's 2 in the front. Take out a 2x. I got x plus 4. 1 is the GCF there. I got x plus 4. So what I'll generally do, and if this is too confusing for you, by all means write it all out again. I come here and say, okay, this is 2x plus 1, x plus 4. How about here? Oh yeah, lots of crap. There's a difference of 2 squares. This becomes 1 minus 2x, 1 plus 2x. Here, what multiplies to negative 2 but adds to negative 1? Negative 2 and 1. Yes, Miss B, that's right. Thank you. I'm glad y'all got the same thing. X minus 1, 2x plus 1. The difference of 2 squares. So since they're both perfect squares, and there's a minus in the middle, you do the square root of the first, the square root of the last. One gets a minus, one gets a plus. Yeah. And then this last one on the bottom, what multiplies to 2 but adds to negative 3? 2 and 1. Negative 2 and negative 1. That's right. So I get 2x, x minus 1, x minus 1. So this factors, it's just a whole lot of factoring is really what it is, which is why we usually get to it in algebra 1, but we ran, algebra 2, but we ran out of time. All right. Now I'm going to rewrite the problem. I'm going to do first times flip of the second. And I'm going to rewrite it so I can really see what's canceling out. But now everything's in factored form, so it should be a lot easier. X plus 4 over 1 minus 2x. I already see something that looks like it might, maybe, we'll have to see. Times, now I'm going to flip over 2x minus 1, x minus 1, x minus 1, 2x plus 1. Again, all the way across. And let's cancel what can cancel first. 2x plus 1. X minus 1. And then what? Okay, so there's something. Do you see that there's something going on here? Do you see what I'm looking at? I'm looking at this one and one of these two. So there's only one in the top. Is there one in the bottom that has completely opposite signs as this? Which one? The first one or the second one? The first one, right? Does everybody see that? Here it's positive 2, negative 1. Here it's positive 1, negative 2. This one's completely opposite. So if I take a negative 1 out of this one, okay? So now watch what I have. I have, all right, up top, x plus 4, 2x minus 1. On bottom, I'm going to take that negative 1 out. That leaves me with negative 1 plus 2x, 1 plus 2x. Now, these are the same. That's not a butterfly. And those cancel. So simplified, I'm x plus 4 Okay, so I found that 2x minus 1 and which one was it? 1 minus 2x. So for this one, if you factor out a negative 1, it leaves me with negative 1 plus 2x, right? I can rewrite that. This is really just about manipulating it around to make it look the way you want it to look. They're exactly the same, they're just negatives of each other. They're the opposites. I guess they're not exactly the same. Does that make sense? Yeah. Yeah. So that negative is going to stay in the problem, but I can cancel those factors out that way. Anybody else? Anything else? Yeah. Monday, yeah. What else?